welcome back to Notes for Evaluating Logs. We're at example 3, where we want to verify that point is on the graph or not on the graph. So we want to circle the points which are on the graph of y equals -3 log base 2 of the quantity x plus 6 minus 2. And if we put in this ordered pair, -4, 5, and we substitute -4 for the x and then 5 for the y, we're looking to see if we get a true statement. So step 1 is to substitute the x from the given point into the logarithm. So I'll have y equals -3, then the log base 2 of the quantity, and then instead of x, I substitute a -4. Then that's plus 6, and then minus 2. So I'm going to evaluate that log now by following my order of operations. So I have to do what's in the parentheses first, and -4 plus 6 is 2. So now I have a -3 log base 2 of 2 minus 2. Okay, I have to evaluate this log function before I can do anything else. So the log base 2 of 2 is 1. So this now becomes a -3 times 1 minus 2. And that is -5. So my y is equal to -5 when I substitute -4 for my x. So I put in -4 for the x, and my output is -5. Does that match what I need it to be? So is -5 equal to the y value in my ordered pair? And the answer there is no. And since I don't get back the y value of 5, that means this is not a point. -4, 5 is not a point on the graph. Okay, so let's try the next one. We're going to substitute 2 into this equation for x and see what we get for the y. So y equals -3 times the log base 2 of the quantity 2 plus 6, because we're substituting 2 from the point into the equation for x, and then minus 2. Okay, we're going to start by evaluating the expression in the parentheses for the order of operations. So -3 log base 2, and 6 plus 2 is 8. So the log base 2 of 8, and then minus 2. So order of operations, we need to evaluate this log expression next. So the log base 2 of 8, that's 3. So we have a -3 times 3, and then minus 2, which is -3 times 3 is -9. -9 minus 2 is -11. So when we substitute in a 2 for the x, we get back -11. And -11 does not match the y value of our point, which is -10. And so that point to -10 is not a point on this graph. Okay, when we try the last ordered pair, 10, -14, we're substituting in 10 for the x. So we have a negative 3 log base 2 of the quantity 10 plus 6, and then minus 2. So that's a negative 3 times the log base 2, and then 10 plus 6 is 16, and then minus 2. And we're going to evaluate that log expression. So the log base 2 of 16 is 4. So now we have negative 3 times 4 minus 2. Negative 3 times 4 is negative 12. Minus 2 is negative 14. So when we substitute a 10 in for x in the expression, so we took 10 here and we substituted it right here for our x, we get back a negative 14. Oh, that's really dark and hard to see. So let's change that to a lighter color like pink. There we go. And when we compare that with the y value that we started with, right, we see that negative 14 does match the y. And so yes, this point is an ordered pair on the graph. Okay, if we look at the graph of negative 3 log base 2 of the quantity x plus 6 minus 2, okay, we can see these 3 points that we were looking for. Can't get a hold of it. There we go. Okay, so we can see these 3 points. There's negative 4, 5, and it's definitely not on the curve. There's 2, negative 10. It's closer, but still not on the curve. And then there's our point 10, negative 14, which is a point on the curve. And that's why when we substituted 10 for the x and we evaluated following the order of operations, we got back the y value for that point, negative 14. Okay, so go ahead and take a look at this error analysis problem where Homer tried to show that the point 0, 2 is on the graph of y equals log base 2 of x plus 4. And here's his work. And he determined that 0, 2 is on the graph. So go ahead and pause the video and see if you can reason out what Homer did wrong here, that 0, 2 actually is not a point on the graph. Okay, so if we take a look at Homer's mistake, okay, here he did not follow the order of operations, right? We have to evaluate the log expression, log base 2 of 0, before you can add 4, right? This 0 is the argument of the log function, so that has to be evaluated before addition and subtraction, which is last in the order of operations. And the log base 2 of 0 is undefined. You can't take an exponent on a 2, a base of 2, and come up with an answer of 0 because 0 is a vertical asymptote. So this point 0, 2 is not on the graph of log base 2 of x plus 4. And that brings us to the secret question for this lesson, where you're going to evaluate these 3 logarithmic expressions without using a calculator and show your work, and then you can upload this as the last page in your notes to Schoology, and you'll enter your answers in the secret question assignment in Schoology.